Hello and welcome everyone to roll call number 11. That's issue 1294 in the PM's repo, link in the chat. I think we're going to start off with updates on what's happening on the L1. So I'll hand it over to Ansgar for that quickly.
Yeah, hey everyone. Nice to see you all again. Let me share my screen. Can you see my screen?
Yep.
Perfect. Yeah, so this time around I called the update ACD and research update because the second part of it will be a bit more kind of forward-looking, more researchy. Either way, starting with the ACD side of things. So we are kind of currently in the process of rolling out Pectra. As we announced kind of on, or like as we talked about on last roll call, the two testnet forks have happened since, Holeski and Sepolia. Unfortunately, with quite some issues. I'm not sure if you, I mean, you might have read about that. So on the Oleski side, we basically there were quite severe issues that it caused like a pretty long kind of period of non-finality. We now have a stable-ish. I looked right now and like it's still struggling a little bit to finalize, but like we basically now have a stable-ish version of Oleski again as of basically earlier this week. And then we had the Sepolia fork that went with that basically had comparatively much smaller issues, just some small EL configuration bugs that very briefly caused some issues, but has been stable basically almost since basically after the fork. Yeah, so if you use either of those for testing, I mean especially Sepolia, of course, then that should be good to go. But as a consequence, because Soleski kind of took quite some time to rescue, there is definitely some delays to the mainnet fork rollout for Pectra. Just maybe for context, both of these bugs on both Holeski and Sepolia were specific to the specifics of the testnet. So none of that should directly affect the safety of the mainnet rollout, but there's still kind of delays as people figure out next steps, especially because there's some ideas around, say, launching an additional test net, given that kind of Holeski had these major issues. Um, all of this means that while there was initial hopes for a Pector rollout in April, now we are looking more at a May timeline. Details to be determined. If you're kind of curious about that, or if that timeline really is important for you, then tomorrow's ACD would actually be a good one to listen in, or maybe even if you specifically want to get involved to attend. Because it looks like there'll be a lot of discussion around this. Um, Now, in terms of how this affects blobs in particular, which I think is one of the major things that the L1 provides for you all right now. So for one, of course, it means that the pectoral itself with the 2x blob increase will be slightly delayed, hopefully, again, by not too much. But then also one thing we are working on very intensely behind the scenes is that we try to make sure that the work on Pia does is continuing basically on track. Meaning the idea was that people right around now that a lot of the CL devs are now shifting more resources towards focusing on ramping that effort up, and that's still happening. So and of course PIADAS is the kind of the piece of the upcoming Fusaka fork that will bring like a large bump to the blob throughput. And so the hope here is that we can ship Fusaka w without like an equivalent delay of like a month plus, and so that we basically still have a relatively short timeline here to this further blob increase. Speaking of Fusaka, I have a slide on this as well. Um, the exact scope is still to be determined, and because all codevs are still busy with basically cleaning up Pectra, it hasn't had time to like finalize the plan there. But I think the most likely scope that we're looking at is really a very small fork that really focuses just on PIADAS, and then on the EL side, UF is this feature that has just been waiting to be shipped for a long time. So now is probably the time for it. And then otherwise really only like small extra changes, like there's some repricing of the modex precompile, maybe things like a minimum blob base fee that we discussed in the past on this call as well. But really kind of like the Fusaka is looking like it's going to be very small and hopefully very fast fork. That's kind of the goal. Um, and then in particular, kind of on these features, there has been a small update on the PIRA side for moving the proof generation for the blobs to the sender. I think Carl, you wanted to briefly talk about this, right?
Yeah. So basically, one of the logic constraints is having the block builder have to create all of the proofs before they can start disseminating this across the network. And this creates a bottleneck because sort of once they're finished building their block, only then can they finish making all the proofs. Um, and this like particularly on um, solo stakers who are running low tier hardware, and if they don't outsource their building to MEV Boost, end up having to have a lot of pressure on them to create these blocks. And uh, the trade-off basically is if we don't enforce that, if we make the solo stakers build these blocks, then and make the proofs, it is much more likely that we're going to have to go with a lower target. So the idea is that if we have a if we outsource this rather to the people creating the transactions, in this case, i.e., sequences, um, then we can we'll have them create the cell proofs created ahead of time, and then B, that means that we can like they already have much higher hardware requirements and much better bandwidth, low latency, and so there's much less pressure on um, the people building the blocks and putting the blobs in the blocks, and so hopefully that allows us to push up the blob target and blob max. So that's sort of where this trade-off space lies right now. The main ask here is that, of course, this now like shifts the burden of creating these proofs, which, to be clear, are not particularly heavy and are highly parallelizable, and can be done ahead of time. Basically, as soon as you've decided what you want in a blob, you can create the proofs. Um, but yeah, putting this now on the sequences as opposed to, or whoever submits the transactions, as opposed to the people including the blobs.
Right. And my understanding is that the EL clients that you would already use to submit transactions, that they will expose functions for that. So I think the idea is just to double check that there wouldn't be any issues for any L2s to basically add this to the pipeline. Shouldn't be, but I think just something to be aware of, right, Carl? I think that's
Yeah, pretty much. As mentioned, it's a very small extra amount of work, so yeah, I don't foresee it being a major thing, and no major like additional work required in terms from like development standpoint, but would change sort of what needs to be done. Um, and just want to check that that's okay, sort of outsourcing this complexity.
yeah, that makes a lot of sense. Maybe we can. I mean, I wouldn't necessarily assume that there's direct feedback on this point, but just in case anyone has already come across this or has any thoughts on this. Yeah, otherwise, yeah, it's really more something to just be aware of. So as we get closer to Fusaka to Piedas, that's just like a small kind of update to the kind of the blob sending pipeline you'll have to be aware of. Okay, then there were two other points where I also wanted to briefly ask for feedback, or at least make you all aware of that there is potential for giving feedback um, over the kind of in the next few weeks. So the first of those 2 points is given that people are really starting to try to rally around this idea of having Fusaka be a as quick as possible follow-on fork after Pectra. Um, there is a question here as we kind of test PIRDAS, specifically because the idea would be on paper at least that PIRDAS could bring a pretty significant increase in the blob throughput. We kind of the theoretical maximum that we could get without increasing load on the weakest nodes on the network would be an 8x increase. So that could get us from Pectra's 6 blob target to like a full on 48 blob target. The problem is that will probably require a while to get to stability. That requires a more sophisticated test, like DevNet approach, where you have to actually like make sure you have a realistic bandwidth topology between the DevNet nodes and these kind of things. And then there might also still be bottlenecks that come up as we kind of push to that throughput. So the question is a little bit, we foresee that there might be some lower throughput number we would get to stability on first, and then we'll have to have the decision point of like, do we keep pushing on the DevNets to try to increase the throughput to this full maximum of 48 blobs, potentially waiting for rollout for the fork for whatever time that takes, maybe a few extra months or something, or do we ship it basically once we reach stability with a more moderate initial throughput increase, say to 12 or 24 or something like that, blobs, and then have people are already starting to talk about these block parameter only forks, BPO forks, where basically we would then have like once we can get to stability for the full 48, we would maybe a few months later we would basically unlock that on mainnet. So the ask here, the question here is just for teams that have some kind of idea of where their blob needs will be. Is this the kind of thing where you'd rather have mainnet wait to then immediately jump to the maximum that we can deliver? Of course, no promise that we could get to 48 at all, but like possibly 48. Or is it something where you all would prefer to just have an initial bump as soon as possible in Fusaka and would be fine with basically the full one coming a bit later? So that's something where, I mean, if anyone here already has thoughts now, that would be good to talk about. And otherwise, it's just something where I think you should be aware that this will be a question that will become important. I would expect like maybe 2 months from now or so. So by that time, you should have a good opinion on which of the two kind of approaches you'd prefer, so that when L1 makes a decision, it can kind of take your preferences into account. But yeah, is there anyone who has a strong opinion today already on what would be preferable here?
Um, Chiming in a little bit from like base perspective, I posted the link in the chat about our stance. So ideally, since we are like already like pretty like heavily involved in PDAS, so our stance is that ideally we would ship PDAS as soon as possible, maybe in September, so that we can have continuous like block target bumps. I think from maybe like realistically from 6 to 24, something like that, will be very good increase. And for later on forks, we could do like block parameter forks with like no hard fork hashes, etc., to ease the pain of like creating a new hard fork. But for further increased blobs, we could do BPO forks and the like to like further push it up.
Yeah, that's really good feedback. And I think, yeah, I realize now I should have probably put on, it's always hard with timelines. I should have put on like some at least approximate timelines to contextualize this a bit more. I think September is indeed, that's kind of like the very best case, kind of optimistic, fast rollout. Of course, there might be delays anyway, right? Even to get to stability on like a somewhat lower throughput number. But September is the kind of thing where if everything goes very smoothly, then that could be in the cards for like if we really try to prioritize rollout and not prioritize getting to the maximum throughput level necessarily. Whereas yeah, if we were to prioritize just shipping at the maximum throughput level immediately, then we are looking really more like trying to do it by the end of the year, possibly even sliding into next year. So yeah, anyone else with feedback? Yeah, I think Francis with Base has already been relatively active. So I think you've already kind of encountered this question in the past. So it makes sense that you had an opinion. So for everyone else, it's really more about like just be aware that that is a question that we'll probably run into, and so yeah, do spend a moment over the next few weeks thinking about what your take on this is. Okay, and then the last one on Fusaka feedback, that's a quick one for me. There has been desire by several kind of core devs to introduce a per transaction cap on how many blobs a transaction can come with. Given that on Pectra we will already increase the maximum blob size to 9, most likely we would not want to introduce a cap lower than 9 because presumably people already have pipelines that use up to the full 9 blobs. So you could imagine a cap at 9 or 10 or something, 12, 16, I'm not sure, something in that range of basically the maximum amounts of blobs that could ever be in a transaction. The idea here is just that like it makes block building and the mempool kind of side of things a bit simpler if you can reason about basically worst case maximum blob sizes per transaction. Um, to note here is that the this cap could later on be lifted or bumped up, right? It's always easier to introduce a low cap and then increase it in the future rather than to basically start without a cap and then basically bring it down later. So it wouldn't necessarily have to be a permanent thing. It seemed from our side that probably there isn't really any specific reason why this would be a very costly change for layer twos. But if yeah, the question here is just is there some L2 maybe that actually really is excited about the um, um, economies of scale effects of sending many blobs at once and would be very sad about such a per transaction cap, or is this just something where people would be fine with that restriction?
If you are thinking about this, I think another component to consider is there are two possible forms that this could take, and one is that if this cap is enforced in the mempool or if this cap is enforced in protocol. This may sound like semantics, but effectively, if it's in the mempool, then if you are communicating directly with a block builder slash relay, then you can subvert that and go up to much higher limits. But if it is enforced in protocol, then that can never be done. So that's one consideration. And so if you're thinking about it, uh, that's yeah, definitely something.
Yeah. And again, our the default assumption is that that's probably fine. So yeah, if there's kind of no feedback now, again, just something where like you should probably just double check if there's any kind of anything that would meaningfully get better. If you could send 40 transactions, 60 transaction, 40, 60 blobs within a single transaction or something, and you'd be really sad of losing out on that opportunity, then that's feedback you should give over the next few weeks. Otherwise, there's a good chance that Fusaka will launch with at least such an initial cap in one form or another. Yeah, that's all from my side on Fusaka. I did have one last slide, and as I said, like a little bit more kind of like longer term, just to give a bit more guidance on kind of what the path here will look like beyond Fusaka, because we have heard from layer twos over the last few months that in general, especially on the blob side, basically having a bit of a better understanding of the medium-term roadmap for Ethereum would be useful. And so, I mean, this is not in any level of depth at all, but just to give you like a very quick kind of rough understanding of kind of where at least right now it looks like the L1 might be going. This is a little bit kind of my attempt of just like summarizing where I think the discussion is at. This might not be fully representative, but just to have a bit of a feeling. So basically we have the medium term and the long term. Medium term meaning like the next 2-3 forks after Fusaka, and then long term, say, think 2 or 3 years from now, basically. So in the medium term, I think on the CL side, there really is now a lot of appetite to focus a lot on blob throughput scaling beyond most other features. There might, of course, there's always like some individual features that are really important on the CL side, like censorship resistance, that might still make it into forks. But I think the main focus will be for the next few forks on scaling the throughput. Basically, there is PRDAS, just even, as we talked about, getting it to this kind of maximum throughput of 48 initially, and then basically just like later versions of this over the next few forks that will continue to bring up the throughput. I think right now we see a good path for another few X bump. And then of course we're now kind of starting to evaluate or like starting to explore what basically the path beyond that will look like. It's not like we have a specific plan there yet, but the idea would be that we make sure that there will always be successive throughput increases coming in the next few forks. And there's more on this maybe soon. There are some considerations right now about different alternative paths and everything. It's not concrete enough yet to be a specific ask, so I'll not go into too much now, but just to flag that. And then on the execution layer side, that's actually a really interesting one. We kind of, for the first time in a long time, on the L1 side, are now working on execution layer improvements again that have the explicit goal of scaling the throughput. I think like Vitalik, for example, had a blog post a while ago, like that basically some sort of like 10x plus minus increase would be important even in a very roll-up centric worldview. And also there's of course a lot of other reasons for trying to have high throughput on the L1. So this is something where like we on the L1 are starting to work on much more in a much more focused way again on. And that's again a departure from, I think, of the last 5 years. There was very little of this work going on, or last 4 years at least. The most interesting point here is that, of course, many of you all are also now working on EVM-based execution systems, and are also currently working on scaling kind of the throughput significantly beyond the current L1 style throughput level. So there will be quite a bit of overlap in terms of techniques, changes that could benefit both the L1 and the L2s. The settings are, of course, not identical. Some things are possible in the L2 that are not possible in the L1, but there still will be synergies. And so the question here, and again, for now, this is not specific ask or anything, but like just keep it in mind. I think a really interesting question here is how can we leverage these synergies? How can we make sure we don't just duplicate the effort? And that any kind of changes that the L1 brings are also then useful for the L2, and the other way around, that L2 improvements that have already been done or that are in the works can also benefit the L1. And then, of course, also how does this intersect with these kind of L2 EVM common core ideas that we've talked about in the past? So basically, I think given that the L1 side here is changing quite a bit right now, this is kind of like an active area where I think people are currently trying to figure out how do we move forward in the best way. Again, no specific ask right now, but like I think if you have thoughts on this, maybe now is not the right time to discuss this, but do reach out to us on the L1 side. I think Carl and I would be good kind of contact points to then route these conversations, because I think having tighter collaboration across EVM chains in the ecosystem on these points, I think would be very beneficial for everyone. Yeah, and then just to round it off, I did put on just to have some context. In the long term, we also have like more kind of step function increases on both of these CL and EL sides brewing. So on the CL, that's kind of, you might have heard about the Justin's kind of beam chain approach, that I would just call it the proof of stake V2, basically, where you just have like a bundled upgrade to a version of the consensus mechanism that has many nice features. Hopefully, like something like single slot or three slot finality, where you have much faster finality, you have shorter slot times, these kind of things. All of this hopefully coming with the beam chain in a few years. And then on the execution layer, and that's maybe a bit more relevant for you all, there is now a pretty focused push on the L1 side towards ZK EVM, and then also native rollups. And of course, ZK EVM is kind of following what a lot of the L2s have already been doing. And then native rollups, it's a bit the other way around. That's more where like the L1 is now exploring, leading in a direction that would become relevant for many of you all. So this is again something where I think our paths will kind of be pretty closely tied together in the future. So yet another area where we have to kind of figure out the best form of collaboration. Yeah, that's all from me on this. Just points that I feel like I wanted to mention. And maybe if you see in chat if there's anything. on this, or if anyone has thoughts on any of this, just now would be the time as well. But again, this was less a request for feedback and more just like some initial guidance, I guess.
Very quick like thoughts, that's in my personal thoughts about Beam Chain. I saw like Justin's kind of like tweet about it. It seems like on the call number 1, we plan to have 8 CL teams, like basically 8 CL clients to do that. It feels like not super necessary. I guess I would. My personal opinion is that to try to cap it at 3 because of the already the big coordination effort we saw on the like current CL like 5 clients situation. So my personal opinion for like things to move faster would be like to cap the number of CL teams or like EO clients in the future, so that we can have less coordination efforts and like much faster implementation speed and much more focus.
Yeah, I think that's good feedback. I think in general context here is that um, while a lot of these kind of proof of stake V2 features have been brewing for a while, Justin specifically came in with this vision of having it be a one-time kind of step function upgrade instead of like iterative rollout for these individual features. So for now, he's kind of the project lead of this Beam effort, and he comes at it with a kind of very specific direction. I think there are still a lot of questions around this, including what you just said. Like, I think kind of how many Beam teams do we need? How does it relate to the existing consensus layer teams? I tend to agree with your take on this, actually. Maybe I wouldn't quite cap it at 3, but I think plus minus, this is kind of what I think we should roughly come out on. I would say though, just for context, like I think given that at least for layer 2s, I don't think many of the features that the Beam chain will bring directly will be so relevant. I think kind of the blob throughput is and then the EL side changes I think are more directly impactful for L2s. Maybe with the one exception of, or like the exception of faster finality and shorter slot times. I think the question is more once we move over to the Beam chain, does it impact the speed at which we can then say, for example, continue to roll out further DA throughput changes, right? And so there, I think we have to make sure that we are in a space where we basically make sure we keep or ideally even improve our iteration speed and are not ending in a situation when now we basically are even slower than we are today. So yeah, but yeah, good feedback.
And one other like additional point to this is that in the beginning with the beacon chain, there were also several more clients that ended up dropping out as development went on. And I think Justin's trying to cover for that, that eventual loss. So yeah, it's I think more based on that and more based on trying to be inclusive and welcoming and saying, hey, everyone can do what they want to do for now and then see where things get us in the future. I think it's very easy to say you want to start a project, but to actually like sit down and ship a client is very hard work, as I'm sure all of you are aware. So I think it's trying to cover for a bit of those losses.
Awesome. Yeah, as I said, kind of a lot of these topics will kind of be more medium term for us to kind of to get more into over the next few months. But yeah, then that would be all from my side for the kind of ACD/research update.
Great, thank you, Ansgar. Next topic is we have Jack Schumer to talk about RRC 7755 and sort of what's the latest happening there.
Yeah, sure. Thanks, Carl. Let me just give me a second to, I'm going to paste a couple links in the chat here, and then I'll share my screen. So here's a demo app that we put together, and then use a link to the current repo. Cool. Can I share my screen? It looks like I am not allowed to.
Oh, sure. Sorry. Give me one sec.
I think I pressed the button now that should allow you to do that.
Awesome. Thank you. Okay. You guys see my slide?
Yep, we got you.
Cool. All right. So, hey, everyone. I'm Jack from the base team. I've been working on RRC 7755. So I'm going to provide a quick update today. So this is previously known as RIP 7755. You may have heard of it as that. It has since been categorized as a request for comment as opposed to a core improvement proposal. So hence the name RRC 7755. It's like an ERC, but for rollups. So this is how it'll be referred to moving forward. To give a little bit of a background for anyone who's unfamiliar, it is a standard for cross-chain calls in the Ethereum ecosystem, but is designed in such a way to be flexible enough to support non-EVM chains in the future. And the core architecture is similar to a lot of the intent protocols that the ecosystem is becoming familiar with now. It relies on three main components. There are contracts for message passing, sophisticated off-chain actors that we're calling fulfillers for relaying messages on behalf of users, and then a settlement layer for verifying call delivery as a precursor to fulfiller compensation. So you can see in the diagram here what this architecture looks like for like the basic happy path route. A user would, on a source chain, submit a request to an outbox contract where the request specifies exact calls to make on a destination chain. And the request is also accompanied by some sort of funds for compensation for a fulfiller to respond. The outbox then alerts the fulfiller network by emitting an event. If the request makes sense, the fulfiller submits the request to a destination chain inbox contract, which is defined in the standard. And the fulfiller also fronts any funds needed for the call execution in this call. The inbox contract then routes the individual calls to their specified targets, and if all are successful, it creates an execution receipt in its storage in such a way that it's like, I guess, considered immutable, like it can't be changed or deleted after it's created. And the existence of that receipt in storage is used as the target of a storage proof that the fulfiller can then generate after a delay to submit back to the source chain outbox contract to prove that they delivered the calls. And if that checks out, the outbox releases the funds for compensation. And this is enabled by state sharing between Ethereum and its rollups. So you can imagine if source and destination here are two L2s that roll up to Ethereum, they are posting state representations to a shared like L1. And then from source chain, if you have an L1 state representation exposed in its execution environment, you can prove something about the L1 state. And like I said, assuming the destination chain is posting state representations to L1, you can then prove something about the destination chain's state. So that's kind of high level how it's working. If you want to learn more, I invite you to read the proposal. So over the last couple of months, we've been doing a lot of testing on testnet. The contracts are currently deployed to Base Sepolia, Optimism Sepolia, and Arbitrum Sepolia for to start with. And all possible routes between these three chains have been successfully tested end to end. So I can confidently say the paradigm works, which is very exciting. And so the contracts for V1 are now in a locked state for audit. And yeah, so that's the current state of the project. To get it to this point, it involved implementing a handful of like state validation provers. And this is because different chains have different data models on L1. So if you want to prove something about their state, there are subtle differences in terms of like implementation details there. So what we have right now is a prover for OPStack and Arbitrum chains based on finalized state. So we'll come back to that in a little bit. And then there was a contribution from the cross-chain alliance team of creating a Hashi prover, which relies on relayed block headers from an Oracle aggregation network that they have called Hashi. And this will be huge for connecting non-EVM chains in the future. And yeah, so Another area that we spent significant effort on in recent months is to add smart account support. So for like the standard request flow or like a basic 7755 request, the payload is essentially like an encoded calls array where you specify the call target, encoded call data, and if any like native value is needed. But we've also added support for the payload to be an encoded user op. And so this supports if users are using smart accounts, they can also relay cross-chain messages here that will utilize their smart account on both chains. And more details on that in the next slide. We'll come right back to it. And then lastly, just a quick shout out. I just pasted the link in chat, but we have a demo app to showcase the 7755 flow. And that's what this link is here and what this screenshot is of in the top right. Feel free to play around with it and let me know any feedback or if anything doesn't make sense. It is not meant to be from the perspective of the end user, where like, for example, if you're trying to bridge funds, you just click send and then your funds magically appear on the destination chain. It's purposely manual and tedious and shows you every step that needs to happen for that to like work out. So when you interact with the demo, you're interacting both as the end user and as the fulfiller. So just an FYI. To dive a little bit deeper on the account abstraction support, to give you some context here, the motivation behind this came from a concern that was raised at DevCon back in November in Thailand of the transaction flow that I went through a couple slides ago being like fine for token swaps or like any arbitrary unauthenticated calls. But in the event that the target destination of the call depends on message.sender, and you would need the sender to be the user, like the requester themselves, then that's where that architecture falls short. So if the user is actually a smart account, there's quite a bit of ERC 4337 infrastructure already widely adopted on many chains that could be reused here in the 7755 context. And that would allow us to route the call through the smart account directly here as opposed to an inbox contract, which would solve that authentication issue from the target's perspective. But then you run into like, if you just have like a naive smart account integration with no paymaster functionality, you run into that the smart account needs to be funded for gas and call execution on the destination chain, which kind of defeats the purpose of one of the built-in invariants of the system, where the fulfiller should be the one sponsoring gas and funds for call execution. So to solve that, we introduced paymaster functionality to the system. That was originally the inbox contract itself, but ultimately decided to separate it into its own contract, but is owned by the inbox contract. And the core, I guess, responsibility of the paymaster is to store deposited funds for fulfillers that are earmarked for sponsoring these 7755 transactions. And so in order for this to work, a fulfiller would have to pre-deposit funds of whatever like currencies they want to support on that destination chain into this paymaster. And the paymaster keeps track of the allocation of funds like between the fulfillers themselves. And then instead of submitting the request to the inbox contract itself, the fulfiller actually submits the user op to the 4337 entry point contract. And so from that point, the request goes through the standard 4337 flow. So I'll skip the standard steps there and just talk about the paymaster, like what's relevant here. For the validation of the transaction, like I said, the paymaster should have pre-deposited funds from fulfillers. So at like the current moment, this requires the fulfiller to be the transaction origin. So like the fulfiller wouldn't be able to relay or like forward the request to a bundler, just like as a call out, I guess. But so from the paymaster's perspective, the fulfiller is tx.origin. And because of the fact that the fulfiller is the one submitting the message, it's kind of like built-in authorization to spend the funds, assuming there is sufficient funds pre-deposited. And so that's like the core idea behind the paymaster's authorization logic here. If that checks out, then the calls are routed through the smart account itself. And that's like the sender from the perspective of the target, like I said. And then after call execution, the entry point calls back into the paymaster with a post-op call, where one of the inputs here is like a call result enum that specifies if it was successful or not. So that allows the paymaster to then validate that the calls were successful, and only if they were, we could create a receipt in the storage of the inbox contract up here. And once that receipt is created, the rest of the 7755 architecture can work as previously designed. And this is secure if the paymaster is owned by the inbox, so that these two addresses are like aware of each other, if that makes sense. So looking ahead, have a couple of, I guess, notes here. This is the repo link that I pasted in the chat where all of this work is happening. Like I said earlier, the contracts are under audit right now. Optimistic they'll be ready to go and be considered quote unquote mainnet ready by the end of Q1. That largely depends on how the audit goes, of course, if there's any findings, how long it takes to address them. But that's just like a rough timeline. Looking ahead, the official proposal is slightly out of date at the moment. All the work that in progress that the proof of concept has gone through in recent months. So I'm spending time getting that up to date. That shouldn't be longer than like within the next couple of days. I should have a PR up that brings the proposal back up to date. So would love feedback once that is ready. The base team will also be spending time working on and building up better documentation and just blog posts in general about the standard, just to spread general awareness and education about how the system works. As a PSA to any solver networks out there, I want to chat with you. Like having the contracts ready for mainnet is one thing, but the system doesn't work without fulfiller support or solver support. So I would love to chat if any solver networks are interested in supporting. I'm currently in conversations with a couple teams, as well as the OIF implementation team, to add 7755 support. So that would be huge, but of course, the more the merrier. Also, as a PSA to other L2 networks that don't fall under the data model category of an OP stack chain or Arbitrum, I want to chat to you as well. If you want your chain to be supported by 7755, we'd have to work together to get a prover set up for like that's customized to your specific data model. Because that's another call out. And then for dev work itself, like I said earlier, the OP stack and Arbitrum provers are based on finalized state, which I think is a necessary feature to have for maximum security. But the problem with that is the opportunity costs for fulfillers having to have their funds locked for like the entire challenge window of an optimistic rollup. So I'm interested in getting provers set up against unfinalized state, where requesters can set their risk threshold of how close to finalization they expect the state to be in order for a fulfiller to be able to prove against it. And this is in an effort like to add a mechanism for making the requests more attractive to fulfillers if they don't have to wait as long. This next idea was from the Arbitrum team or Off-Chain Labs team to add caching solutions to prevent verifying the same state twice. So that's kind of like an optimization idea that I plan on working on in the near future. And then lastly, I'm very interested in checking out verifying ZK snarks of storage proofs and seeing if that can be used as an optimization technique. In the examples I've gone through so far, the route is just like L2 to L1 to L2. So there's those two hops of proofs that are needed. But once L3s and beyond are in the picture, you can imagine proof routes could get more and more complicated. And so having a way to verify these proofs of routes that increase in complexity without the proof verification increasing in complexity, I think would be very valuable. So it's just a couple ideas that are going to be top of mind as we move forward. And that's all I have for today. So yeah, thanks for your time. And let me know if there are any questions or concerns or just want to chat about any of this. I'll be around on Telegram and X and all that fun stuff. So
Thanks, Jack. Can I ask a question really quickly?
yeah.
Yeah, I was wondering, so like if do you guys are all your transactions atomic, or like what happens if I need to do like a refund to the paymaster in the middle of the transaction?
Let's see here. So can you explain like exactly what that situation would look like?
Yeah, for example, like let's say the final call fails, then does the paymaster lose its gas deposit? So like maybe, for example, you're allowing for some partial execution. So some of the steps will succeed and others will fail. Or maybe you just want a fully like atomic transaction where either
I
everything
see.
is successful or not. So I was just wondering which one you're doing.
I see. Yeah, right now it's fully atomic, so they either all settle or none of them settle. Or at least that's the intended idea of the design here. And yeah, so that the storage receipt will only get created if all of the calls are successful. I guess I'd have to look deeper into it in terms of the 4337 infra, if some of them succeed and some of them don't, how that refund mechanism works. I'm not sure off the top of my head. I'd have to look into it.
Yeah, and then the other question I had is, let's say if the user triggers a bunch of different calls in quick succession, how do you guys handle the ordering? So, like for example, with smart accounts, you can have 2D nonces. So are you guys using that nonce, or how are you doing like the ordering?
That's an interesting question. So the standard uses a canonical nonce as well, but mostly for ensuring that every request is unique in terms of the ID generation, because each request gets an ID that is a hash over the request data. In terms of how the fulfillers order the transaction on the destination chain, there's nothing in the like core architecture that enforces that. There is, I can point to the proposal itself. There is a pre-check mechanism that could probably be used to enforce ordering if we wanted to do something like that. But the core contracts that I went over today are unopinionated about transaction ordering.
Okay, well, thanks for clarifying.
Cool. Thanks for your time, everyone.
Or may I just ask one more quick question?
Yeah.
Presentation. Curious how you think about this in relation to the super chain interop stuff. I know that obviously there's super tight coupling involved there, and I know they don't necessarily wait for finalized blocks to finalize the or to, from a user perspective, have the call go through. And just kind of curious how your solution relates to that, and then how the user experience will relate given the extra lengths that interop seems to be willing to go right now.
Yeah, I see. So it's kind of like a separate solution. And the way we've thought about it up to this point is that the superchain interop solution could be like the core interop choice for being within OP stack chains. And then 7755 could be used to bridge from superchain to external chains in the ecosystem. It still requires building OP stack provers, because if you're sending messages back into OP stack chains from outside of like that network, superchain interop isn't relevant there. Like you'd need something to bridge that gap. So that's kind of how I'm thinking about 7755. And I forget if there was a second part of your question.
How close do you think you can get the user experience on the more general solution, which is yours, to the more specialized solution, the interop thing?
I see. In terms of like the user-facing interface that you would work with. I don't have an answer for that off the top of my head. I'll make a note to circle back around on it.
Cool, thank you.
One extra question. Could you quickly run the demo through the Versal app? If you can share your screen and run the demo, that I think would be great, even to share later on social media or wherever.
Sure. Yeah, give me 1 second. Sorry, yeah, I didn't see the hands raised when I was sharing my screen earlier.
No worries.
Okay, so let's say we connect. Okay, so yeah, this is the demo site. It right now is set up so that you're working on behalf of a mock account, and this like the base setup that the site loads with is you're bridging some amount of ETH from Arbitrum Sepolia to base Sepolia. And so that's what these steps are gonna like walk you through. As a first step, it assumes you have to pre-fund your mock account. Mine's already funded, but I have not added a way to skip a step. So we're gonna go through it anyways. Let's say we want to bridge 0.1 ETH. So we'll go ahead and transact to pre-fund my account on Arbitrum Sepolia. Transact. Confirm. Oh, sorry. Give me one. I'm going to stop sharing to get this password.
Sure. Sorry about that.
Oh, yeah, it's all good. 1 second. Okay. Here we go. Okay, so you can see here we just had the 0.1. It might have gone through twice because of my redoing it, but I pre-funded this account with 0.1 ETH. So now from the destination chain side, we'll have to pre-fund the paymaster, and this is because of the 4337 flow that I walked through in the slides. We have a paymaster deployed to base Sepolia, and by default, it is for supporting user op submission to destination chain. But to support better capital efficiency, you can also use the paymaster like for regular accounts as well. So from the fulfiller's perspective, this is what I have in test ETH. We can go ahead and transact to pre-fund the paymaster with the 0.1 ETH that's going to be needed for the call execution. So we'll go ahead and add this. So that's where this is coming from here. And I forget if I said earlier, but the purpose of this demo is going to be to bridge what I set here, 0.1 ETH from this account on Arbitrum Sepolia to this account on base Sepolia. So the first step here is going to be to, so these first two steps were kind of like to set up the scene for like having this ready for that bridge transaction. Now we can start, like this is the first transaction, first and only transaction from the end user's perspective, where you submit the request to bridge the ETH from Arb Sepolia to base Sepolia. So we'll go ahead and transact. This is going to create the 7755 request with an encoded call array of essentially transferring that amount of ETH from the destination chain inbox into the account. It's like into the account here. And so what's going to happen is the inbox will pull the 0.1 ETH from the paymaster, then execute the call that says to transfer the ETH into the account itself. And I'm confused why this isn't, the demo gods aren't on my side. Something must be going on with the balance update, but we'll proceed. Oh, sorry. I forgot where it was. We have to fulfill the request to see the balance update on the destination chain. So all good. What we should have seen there was the 0.1 go from the account into the outbox on source chain, which it did. And what you're seeing is 0.102. This is adding just a hard-coded 2% fee on top of the value as the compensation for the fulfiller. This is kind of like a naive approach just for demo purposes. In like a production environment, there likely is going to be some more sophisticated mechanism for pricing what these transactions are going to cost, but that is an unsolved problem at this point. So now on the destination chain, as the fulfiller, we will fulfill the request. And now is when we should see the paymaster balance get pulled into the inbox and then routed to the account. There we go. And at this point in time, from the end user's perspective, this is done. Like the end user got 0.1 out of their account on Arbitrum Sepolia, and it showed up in their account on base Sepolia. So like they can go on with their life like nothing else is happening here. But now behind the scenes, the fulfiller needs to come back to source chain to claim their compensation out of the outbox here. And the way they do that is by generating a proof of that execution receipt in the destination chain's inbox contract. So that's what this step is going to do. And for the demo, because we don't want to have to wait for base Sepolia finality on Sepolia, we're using that hash prover that I mentioned, which is going to relay block headers from base Sepolia directly to Arbitrum Sepolia and then prove against that block header. So that's what this proof is doing here. It just looks like a bunch of numbers and letters, but I figured it'd be useful to see what it actually looks like. If we go to the next step, this is now going to trigger sending the base Sepolia header into Arbitrum Sepolia. It's just necessary to be able to prove against for the demo. This is a step that would not be needed in a production environment. And yeah, so now that that's there, we can claim the reward. So this is going to use the proof from this step here, and that'll result in pulling the 0.102 ETH out of the outbox and into the fulfiller. So we go ahead and transact there. Should see the balance update in a second, hopefully up here. If it doesn't, I might just have to refresh. Yeah, I just had to refresh. So we pulled the 0.102 ETH out of the outbox, and it's now in the fulfiller, and that closes the loop on the transaction flow. That's about it. So the demo, so that's like kind of the basic setup that it is pre-configured to show. But you can also, like I added a mock USDC, so you could mint yourself some mock USDC to play with that and see how the flow changes for like using an ERC20. And then it also shows smart account flow. It might be kind of confusing because this doesn't actually have you use a smart account, at least with the way the demo is set up. This just creates a user op under the hood and then has the fulfiller submit it to the entry point contract on destination. But I guess it's just confusing because from like the UI perspective, it's kind of doing the same thing, but under the hood, it's actually a user op. So that's what's happening here, just to show that it's supporting both request types. And then we also have Optimism Sepolia in here, so you can try different chain connections or combinations, and yeah, feel free to play around with it.
Great. Thank you for the demo. Very interesting.
Yeah, thank you.
Yeah, that was amazing. Thank you very much. Another question is it possible to have some kind of like callback to the originating chain? Or would that have to be like as a part of the proof that's normally generated? Or would you have to make that a second 7755 call from the destination chain back to the originating chain?
I think as a first pass idea on how that could work, it probably would have to be a separate 7755 call. But if you make one of the encoded calls in the request, another 7755 request coming back into the outbox on that destination chain, you could probably do it that way. The contracts
I didn't think of that.
the contracts themselves don't have like a callback mechanism, but it should be flexible enough that you can encode a call, like another 7755 call within the original request, if that makes sense.
Okay, cool. Thanks. Okay, well, thanks very much for that awesome demo, Jack. That is all we really have time for today, but thank you all for attending and chat all async. Yeah, please appreciate feedback on all those PRS topics mentioned earlier. And yeah, have a great week.
Thank you. Bye, guys.
Thanks, everyone.
Thank you.
Bye.